I'm Andrew Thaler, and this is the OpenCTD. A CTD is an oceanographic instrument that measures salinity, temperature, and depth. It is the workhorse of oceanography. Almost every marine science project begins with a CTD cast. Almost every piece of ocean conservation data is tied to a CTD cast. Without CTDs, scientists, managers, and conservationists would be blind to the invisible patterns beneath the waves that shape our oceans. But commercial CTDs are expensive. This means that the vast majority of ocean stakeholders lack access to this fundamental tool. Often the people most directly impacted by warming oceans and rising seas lack the tools necessary to measure those changes. So I created the OpenCTD, a low-cost, open-source CTD that can be built for a few $100s to help bring down this barrier to entry and put the tools of ocean science into the hands of anyone who wants to study, monitor, and understand their changing oceans. The OpenCTD is assembled from relatively accessible components provided by major electronics manufacturers and hardware available in most general hardware stores. The brain of the OpenCTD is an Adafruit Adalogger M0 mounted on a custom PCB combined with a real-time clock and an EZO conductivity circuit. The brain is protected inside a 3D printed chassis that also holds the battery, and everything runs on Arduino. The sensors are made from a 14-bar pressure chip, DS18B20 temperature sensors, and a graphite conductivity probe. Over a serial connection, they provide a real-time stream of environmental data, and in the field, the data is logged on a bog-standard microSD card. The housing is made from a 12-inch Schedule 40 PVC pipe, sealed at one end with high shear strength epoxy, and capped at the other end with a pressure test cap. Casting the CTD is as simple as turning it on and lowering it slowly down into the water column. It can be submerged up to 140 meters. It can be cast by hand from a pier or boat, affixed to other equipment being deployed, or placed on a permanent fixed mooring. We've launched CTDs via fishing rod, strapped them to lobster traps and trawl nets, anchored them to the sea floor, set them out in hurricanes, and of course, tied them to commercial CTDs to assess data quality. I can only build so many CTDs, and our goal has always been to create something that people can build themselves. So we've created an extensive, freely available build guide, released all the source code and shape files online, and I've been prototyping a classroom kit so that teachers can lead their students through the OpenCTD build. I want the tools of ocean science to be available to anyone, regardless of funding. I believe that the ocean belongs to all of us, and that the tools to study the ocean should be available to anyone with the curiosity and motivation to pursue that inquiry.